Hi, if you've clicked this, you may be one of my students in the REACH program, or maybe you just saw math anxiety and said, I know all about that from personal experience or the experience of my son or daughter, and I want to know a little bit more about it. So I'm going to tell you what the research says and some things to know about math class that might help you or the people you know deal with math anxiety. So just to review, what is math anxiety? And this question, is it holding back achievement? We have a pretty familiar definition. I take it from Zhang, 2019, but a very similar definition goes all the way back to the 80s. The state of fear, tension, and apprehension when individuals engage with math. So it is an affective or emotional state, and it's not necessarily a set of behaviors or a cognitive set of processes. That's sort of up for debate still. Studies have reported diverse findings on math anxiety's impact on student performance. Some have found strong correlations, saying that anxiety correlates well with poor performance. There's an inverse relationship. And others have shown no relationship at all. And this shouldn't be that surprising to us because we see math anxiety among high achievers. So depending on how the studies do their measurement, it's going to be difficult to determine whether the relationship is causal or even there at all. It may be misleading to examine the influence of math anxiety on math performance without looking at the effects of other self-perceptions such as expectancies and values. So there are a lot of other influences that determine whether a student achieves their best in math, and those are their attitudes toward the value of math, whether they have a strong sense of themselves as a math student, and that's not quite the same, but may overlap with math anxiety. And, of course, teaching and the classroom environment make a big difference in how anxious the student feels and how he or she achieves and performs. So I've used this word relate. How might math anxiety relate to performance? It's not necessarily a cause. You could see this first theory as almost a cycle. The deficit theory says that poor past performance or poor attitudes about math lead to anxiety, which lead to decreased engagement in the subject, decreased preparedness during, say, test time, and an ongoing cycle of anxious and disengaging behavior. Now, many students would readily attest to math anxiety impacting their performance, and one theory that addresses that experience in that process is cognitive interference. During math, you need working memory, but different types of tasks and different approaches to problems can require more or less working memory. Students who have greater working memory have actually been shown to be more vulnerable to the effects of math anxiety. So they may be used to, in less stressful settings, using a greater working memory for their math problem solving. And then when they get stressed out or anxious, they are unable to utilize that. For example, if you're looking at these different ways to solve 18 times 5, then you could see that some of these require multiple steps, and a really simple way to do it that would require almost no memory would be to just count by fives to 18. It's very automatic. There's room for error, and it's not a great method, but I don't have to keep anything in my working memory. I can just keep it on my digits. So that's using some math skills, but it's very different. And if you just, say, revert to trying to find a formula instead of understanding a problem, then you might suffer from the effects of math anxiety. On the other hand, math anxiety isn't necessarily all bad. Just as stress, and it could be good stress, that motivates and drives someone forward, energizes, the same can be true with math anxiety. At least in one study, where here in the graphs we can see best fits for students identified as having high or low mathematical motivation and different levels of math anxiety. the achievement numbers on the vertical axis show that the dotted line, the highly mathematically motivated student, has an optimal range of math anxiety. Now, for applied problems, maybe that optimal range is pretty low, and you don't want to be anxious during a difficult problem-solving activity, but a little bit of math anxiety when doing estimation tasks might actually just spur someone on to make a right guess. So what we could take away from this, especially with the mathematically motivated students doing better than the less motivated students, is that fostering intrinsic motivation is possibly as important as decreasing in anxiety. And that's something that students can do, and it's also, of course, something that teachers and parents can do. So, what teacher practices increase math anxiety? I don't want to jump to blaming the teacher for math anxiety. It does correlate with general anxiety, but some settings are more anxiety-inducing than others, and students have reported that teachers who appear hostile, condescending, impatient with students who ask questions or need more information and help, and of course teachers who demonstrate insensitivity or stereotyping are going to increase anxiety. Two other things though, fast instructional pace and time constraints are commonplace in the math classroom, where notes are delivered quickly to students and they must write them down, and then the bell will ring and then homework is assigned. Or time constraints on a test to see whether a student can complete the assigned number of questions in the amount of time allowed aren't really necessarily what mathematicians deal with in their future, or problem solvers in the real world need to practice in school. So there are parts of the math classroom that may not need to be there, but are a big part of math anxiety. How can parents influence math anxiety? Well, a lot of this work's been done at the elementary level, but you can imagine it transferring up to the middle grades as well. Parents who help with homework have been shown to actually sometimes increase math anxiety for their students when those parents have poor math self-concepts or math anxiety themselves. They might be expressing attitudes about failure, about mistakes, or about math in general that lead the student to have more math anxiety. At the same time, parents can help with math anxiety by creating more math exposure at home. That means maybe not just helping with homework, but working with numbers and math problems independent of what's sent home, to make math enjoyable and to let students practice struggling in a positive environment. So what teaching practices and maybe even parenting practices carry the benefit of reducing math anxiety and enhancing learning? The first slide I have on this is about growth mindset. And Dweck's ideas about growth mindset have now become widespread and a movement in education. She tells us in a recent article from 2015 that coaching a growth mindset is not simply about praising effort, saying, "Good job, you tried your best," but providing specific feedback. Things like, "Let's talk about what you've tried and what you can try next." That kind of thoughtful, aware, and confident approach to learning is the opposite of math anxiety. Teachers provide specific praise instead of normalizing fixed mindsets or negative math identities. And some elementary teachers come to their practice with math anxiety themselves, and that can impact students' achievement, especially for girls with female teachers as role models. So teachers need to maintain a positivity about math and not say, "I was bad at math too." That implies that the student is inherently bad at math. Now, in her own work, Jo Boaler would promote a more extreme version of this next bullet point, but teachers should provide increased individual diagnostic feedback instead of such frequent graded tests and quizzes that cumulatively build a student's grade, while in theory the classroom is supposed to develop a student's readiness by the end of their learning and their schooling. On the other hand, Dweck remarked, if we use mindset measures for accountability, we will create false growth mindsets on an unprecedented scale. So we still need to assess for performance and achievement, and that can't be a source of anxiety. Students need to be able to come to grips with and grow from feedback that says how well or unsuccessfully they're handling the math work given to them. In terms of lesson planning, teachers can go a long way to reduce math anxiety by enhancing learning and changing the way the math classroom feels. First, they should be teaching problem-solving strategies to enhance students' self-efficacy and self-regulation, so that students are ready to tackle problems they haven't seen before, and so that dealing with difficult problems is the norm in math class. On the other hand, they should be limiting the value placed on merely procedural tasks, trying to enhance conceptual understanding. Another way to do that is to utilize groups and collaboration where students explain to each other their justifications and strategies and approaches in their own words and in a variety of ways, and assign open-ended problems with low floors and high ceilings. To conclude, I'd like to offer 2 resources that teachers and parents can use to find those low floor, high ceiling tasks that will help students struggle productively to become better math students. And one is U Cubed. Joe Bowler, who I've mentioned before, was involved in this project, and you can find tasks sorted by grade level and subject area, and you can pull up an easy drop down. The problems, again, start very easy and are guided step by step to get students to see concepts in deeper ways. Worksheets and solutions are available, so you don't have to be a mathematician to now have these kinds of creative resources. The second resource is Enrich, and it's from the UK, so some of the grade level organization is a little bit different, but they have a very nice granular approach to dividing these tasks and activities under different topics. So if I go to number, then it breaks it down even farther to say powers and roots. Here you'll see an activity about generating Pythagorean triples, and it really does progress the student up to a high ceiling, and this wouldn't be for elementary students by any stretch, but I think that these are ideas that will get students challenging themselves and becoming more comfortable with the demands of real math instead of algorithmic procedural math that leaves students anxious and unprepared when they face new and novel experiences in math. I have some references, and I wish you good luck and a moderate level of stress in your future math. Thanks.